Assalamualaikum warahmatullahi taala wabarakatuh. So today we need to understand still in the capacitor. So the question is, if a dielectric material is inserted between the parallel plates so of the capacitor, so complete the statement below. So we need to understand what happened to the capacitor if we put the dielectric material inserted between the parallel plates. So before I continue, I draw the diagram here. Here is the plate. So this plate is connected to the positive terminal, so the charge positive is here, and then here is connected to the negative plate, so store the negative charge is here. So here is the positive plate, here is the positive plate, and here is a negative plate. Okay, so and then we put the dielectric material here. So we put the dielectric material here. I draw this one like this, so between the plates. So this one is a dielectric material. It can be anything. Normally we use a wax paper or the paraffin oil or whatsoever as a dielectric material. So here is a dielectric material. Okay, so then before we continue, because here is a positive plate and then here is a negative plate, so we can draw the electric field line. So here is the electric field lines. So it's from the direction is from the positive to the negative, and then I put as E. So the electric field line, it must be from the positive plate to the negative plate. Okay, so dielectric material, so it can be anything. So then what happened to the dielectric material? So the dielectric material, so here is a positive plate, so all the negative charge will move here. Then here is a negative plate, of course the positive charge is here. According to the Newton's Coulomb's law, according to the Coulomb's law, here is a positive, negative, so different charge. So the charge, the negative charge will experience the attractive force. Then they are moving from to this side. So negative, positive, negative, so attractive force. Same with the positive. Here is a positive charge, so they are moving here. Why? Because here is a negative plate, so they will experience the attractive force between positive and negative. So then what happened to the dielectric material? Okay, so we continue. So the dipoles, so the dipoles in the dielectric material. Dielectric material actually is rearranged. So the dipole, so dipoles in the dielectric material, they start to rearrange. So dipole, that means we have the two poles. So here is a negative pole and here is the positive pole. So that's what is meant by the dipoles. So the dipoles in the electric field, the dipoles in dielectric material is rearranged. So we continue. So the positive, So the positive poles. So the positive poles face. So face the negative plates. Yeah, so the positive pole is here, so to face the negative plates. So this can be explained by apply the Coulomb's law. So why? Because the difference in the sign of charge, so they will experience the attractive force. So we continue. So the negative poles. So the negative pole face so the positive plate. So this also can be explained by using the Coulomb's law. Okay, so the negative pole, where is your negative pole? Is here. So to face the positive plate. Why? Because they're different in the sign of charge. So they will experience the negative. We will experience the attractive force. So we continue. So this situation or this phenomenon called as what we see in is a polarization. So normally we call as a polarization. That's mean polarization. So they produce the dipoles. So the dipoles of molecule or atoms. Dipole, that means we have the two poles, positive pole and then the negative pole. Okay, so we continue. So the net, so we continue with the net electric field. So the net electric field, actually what happens is decreases. Why? Okay, so we go here. So we go back to this diagram. So we have the E. E is electric field. So they produce. So E is produced by the, because here is a positive plate, here is a negative plate. So the experience, the electric field is from positive plate to the negative plate. Okay. So I go here is the net electric field. So explain you the E. So minus. So look here. So here is a positive poles. Here is a negative pole. They also produce you the electric field. So the direction is from positive to negative, and then we label as a EP. So that means is a P, because the negative is opposite direction with this E. E is here, EP is your electric field produced by the polarization. So we take notes here. What is a EP? HP is the electric field. So the electric field, so they are produced. So produced by the polarization. So that means the polarization of the molecules, so they produce the extra electric field, then we call as a EP. The electric field produced by the polarization. So that's why your electric field is decreases. So then we continue. So the potential difference. So the potential difference across the plates. So what happens? Also decreases. So the potential difference across the plate also decreases. So we continue. So this can be explained from this equation. E is equal to the V over D. D is the distance between the plates. From here to here is a D. Okay, so from the equation, when E is increases, so the equation show the potential difference across the plate also decreases. Okay, so we continue. So the charge. So the charge, that means stored by the capacitor. The charge on the capacitor, stored by the capacitor, is the remain constant. Is constant. So then we continue. So we draw the equation. We write the equation from equation. Q is equal to the CV. So we manipulate the equation. Then we can write as C is equals to Q over V. Okay. So then from this equation we can see C is inversely proportional. So the inversely proportional to the V, potential difference across the plate. So what we can see here, therefore what we can see here, so when potential difference V across capacitor, actually the plate of the capacitor is decreases, then the capacitance C of the capacitor is increases. Then the increases. Okay, so actually is the concept. So actually the explanation what happen if we put the dielectric materials, and then how they can increase the capacitance of the capacitor. So you put the dielectric material inside between the plates of the capacitor, and then all the step is explaining how the capacitance can be increases. For that is a thank you.